Okay, so this is part 2 of the DC circuit review, and this is Horner. Consider the following circuit. It includes both resistances in series and parallel. So just to kind of review a little bit, let's remember what parallel and series means. If I draw a loop for here, and remember the loop rule, all the voltages should add up to be 0. If I go all the way around this loop, notice there's one loop. Let's go through the other loop, and we'll make this one red. And if I go through the other loop, notice the only resistor that I touch twice is R1. So this one is in series, and these right here are in parallel. So the two here along with this one, these two are in series, but when you put them together and make them one resistor, which would be R2 plus R3, then R2, R3 is parallel with R4. And this is a combination circuit because of that. It actually has a series within a parallel, and then we have series and a parallel, so that would definitely be a combination circuit. They want us to draw an ammeter, which measures the total current in the circuit. So to do that, you simply just put the ammeter right after the battery. So we're going to put the ammeter right here in line with the circuit. So this would actually be attached to the wires, one on one side and one on the other side. Next thing that they want us to do in terms of an ammeter is to put A2, so this is A1, which measures the current only through R4. And so if I want to measure through R4, I'm going to tell you if you can put them after the resistor, that usually works pretty well. So this one is A2. I could have also put it here anywhere after this junction, so I would mark the junctions. So there's my junctions. Anywhere after this junction, up through this resistor, and then up to this junction you could put it. So it could go here, it could go here, could go here, or here. Any of those places as long as it's just in this little block that has R4 in it. For A3, they want us to measure either the current R2 or R3, so the best place to put it would be right in between the two, because we know in series, because of the junction rule, both resistors end up with the same current. Now they want us to draw voltmeters to measure potential difference. They first want us to do one V1 so we can measure across R1. These we always put in parallel, so we want to draw our junctions in front and behind. Then we'll draw our voltmeter, and remember this one is in parallel because in parallel the voltages are the same, so that won't mess that up. The reason these are in series is because in series you don't mess up the current with your meter, and that makes it nice too. Voltmeter 2 measures voltage across R3, so I'm going to put a dot here and a dot here, and then I'm going to put my voltmeter in parallel with R3. So this one is V2, this one's V1, and the last one is V3, which measures the voltage across both R2 and R3. So we'll put one there, put the V here, and come back down and then come back over. And now I have a voltmeter 3, which measures the resistance across both R2 and R3. And that is the simplest solution that you will have for one of the problems. So that's number 4. If we go ahead and take a look at the next one, which is number 5, in this one they want us to draw a 12-volt battery and two resistances of 6 ohms and 8 ohms connected in series. They want us to make an ammeter in the circuit to measure current in the 6 ohm resistor, and a voltmeter to measure the voltage across the 8 ohm resistor. Then it says calculate, so we've got to show work, the current passing through the 6 ohm resistor and the voltage across the 8 ohm resistor. So calculate means you have to show work. So let's draw our circuit first. We'll do this one in blue. When we draw this circuit, probably the simplest thing to do is go ahead and start with a battery. So there's our battery. We know that this is 12 volts. And we have two things that are in series. So let's come over here and we'll do a resistor and then come down and back over, do another resistor, and then come back up. Now notice geometrically these are in parallel, but because there's only one path, they are actually in series. This one is 6 ohms. This one we know is 8 ohms. We're going to place an ammeter in the circuit to measure the current in the 6 ohm resistor. So that's pretty easy to do. we can just put it right after it. And remember, in series, it really won't matter where we put it. It will measure the current in the whole circuit. So no matter where this is, it's going to measure that current. They want us a voltmeter to measure the potential difference across the 8 ohm resistor. And so there is our voltmeter, and we are set there. Now they want us to calculate the current passing through the 6 ohm resistor. So what is this? And then they want us to find the voltage here. So let's go ahead and think about using a VIRP chart. I'm going to move this thing over here. We're going to set our VIRP chart way over here, VIRP. We're going to use it to help us calculate some things. So the two things that we have that are resistances are 6 and 8. So I'm going to put 6 and 8 and then a line. 6 and 8 is 14. At that point, we need to look at, and remember this is the total resistance in the circuit, and it is a series circuit, so we can even put RS, that might help. We have 12 volts. Now we need to calculate what that current should be, and so we'll do that next. And remember that current is voltage divided by resistance, and we're just using the table now, it's just a tool. This will be 0.86 amps. And because this whole thing is in circuit, and because of the junction rule, everything should be 0.86 amps. Last thing they want us to do is figure out what is the voltage across the 8 ohm resistor. So we're going to take 8 times 0.86, and you end up with 6.88 volts. Now we need to show all that work. So to show that work is pretty simple to do. We're going to start by going back, and we remember we did the resistances first. So we're going to say the resistance in series is equal to the sum of the individual resistors in series. There's our equation. Next thing we need to do is put our numbers in, 6 plus 8, and that is equal to 14 ohms. Now we can put in the next part, which was finding this number, which was current. So we know that current is equal to voltage over resistance. The voltage here is 12 in the entire circuit. The resistance was 14, and when I divide those, I ended up with 0.86 amps. I went ahead and put the 8.86 there and there, and we want to now find the voltage in the 8 ohm resistor. If I want the voltage in the 8 ohm resistor, that is equal to the current times the resistance in the 8 ohm resistor. And so that is equal to 0.86 times 8. And that will give us a value of 6.88 volts. So we found the current in the 6 ohm resistor because we know that it is the same as the current in the circuit. We found the voltage in the 8 ohm resistor because we know that the current in that 8 ohm is also 0.86 times the resistance, which is 8. And so here is the voltage, or the potential difference in this resistor. That one is question number 5. Let's go ahead and do 6. So if we skip through and we take a look at the next one, which is 6, they want us to find the reading on each ammeter and voltmeter in the following circuit. It's another series circuit. We need to do a VIRP chart again, so let's just do V, I, R, and P. Our resistance is 20, we have 16, and we have 8. So we'll do our single line again because we know we're going to get everything in series. If you take 20, 16, and 8, you end up with 44 ohms. That's the total the total resistance. And then the voltage here is 11, so I'm going to put 11. Notice that they need us to find out what is the voltage for each one of these 3. And they want the current both here and here. But remember, it's in series, and because of the junction law, all of these junction rule will have the same current. So let's go ahead and find that current. We're going to take 11, and we're going to divide that by 44. And if you take 11 divided by 44, you should get 0.25. So this is 0.25, and because it's in series and because of the junction rule, they all have the same current, which is 0.25. Now that I know what these are, I have to find the voltages. So Here, this current is 0.25. This one is also 0.25 amps. For the voltage, we want to take and we need to find the voltage for each one. So at this point, I would go ahead and start writing out my work. I know that the resistance in series is equal to the sum of the individual resistances in series. That is equal to the 20 plus the 16 plus the 8, and so we end up with 44 ohms. So that's the first part that gets you points. The next thing is to find out what is the current in the total circuit. That's equal to the voltage over the resistance. We know our potential difference here is 11 divided by 44 ohms of resistance, and we end up with a total current of 0.25. Now we want to find the voltage in the 20. We want the voltage or the potential here in the 16, and find the potential in the 8 ohm resistor. So this is equal to the current in that times the resistance. This is the current times the resistance for the 16, and finally the current times the resistance for the 8. Our current is 0.25 in each case, so I can go ahead and write all of those in. And then we have our resistance. Resistance for the 20 is 20, resistance for the 16 is 16, and then finally the resistance for the 8 is 8. Let's find the voltages or the potentials now for each one. 0.25 times 20 gives you an answer of 5. So this one is 5 volts. So I know that this meter is giving us 5 volts. If I do a quarter of 16, I should get 4. And this is 4 volts. So I know this meter would read 4 volts. And then finally, if I do 1/4 of 8, I should get 2, and that is 2 volts. So I put my 2 volts in. This way you'll get all the points, and that explains kind of what's going on, and you can put all of the values right next to the meters, and that makes sure that everything is good. This will not get graded, so when you do this, remember, is a tool like your calculator. You don't turn your calculator in, so you can't turn this in, and that is numbers 5 and 6.